Hello students, how are you? Welcome to my geography class. Today's topic is movement of the earth. As we have already discussed that there are two types of movement of the earth. There are two types. Two types means one is rotation, another is revolution. So today we are going to study what is revolution. We are going to discuss the definition of revolution, concept of orbit, and also the effect of revolution. So movement of the earth, revolution is today's topic. So first coming to the definition of the term, or what is revolution? Now revolution, as already I have mentioned, is the movement of the earth how and where it is going. It is movement of the earth round the sun on its own orbit in an anti-clockwise direction. So here we are getting from this definition, there are different concepts that we are getting. That is, first we have mentioned that it is movement of the earth. That is point number A. Then it is around the sun. It is how, where it is revolving. It is revolving round the sun on its own orbit. Now what is orbit? Orbit is the path, and how it is going? It is going in an anti-clockwise direction. So B is orbit and D is anti-clockwise direction. So from the definition of revolution, we can see that there are four features or four distinct kind of things. That is, movement of the earth round the sun on its own orbit in an anti-clockwise direction. So if you can remember these 4 points, you can put it into a sentence and there your definition is complete. So from here we are springing up to some new concepts, that is around the sun. It is moving around the sun. So how it is moving in its anti-clockwise direction and on its own orbit, orbit of the sun, orbit of the earth. And it is in an anti-clockwise direction. What do you mean by anti-clockwise direction? Now suppose if we see a clock, that is, this is a clock. So generally what happens, a clock goes from this way, from 12 to 6 to this. So whenever we say that, and this is clockwise. So anti-clockwise means whenever we see that the movement is not this direction, the movement is just the opposite, like this. Means if this is the center, then it will go like this. Okay. So this is called anti-clockwise direction. This is anti-clockwise, that is movement that is against the clockwise direction. So when our earth is revolving round the sun, so if we see this is the sun and this is the orbit. Now our orbit is not spherical in shape or roundish in shape, it is elongated in shape. So this ellipse kind of a thing is the orbit. Now what is, and the earth, if this is the earth, this earth is moving like this. So this is the movement of the earth round the sun is called revolution. So this is called revolution round the sun. Now this revolution, how long it takes? What is the duration or time to take one complete revolution? So one revolution is equal to 365 and quarter day. That is 1/4 day. 1/4 day means 6 hours. But in 1 year, so we are getting 365 days means 1 year. But this 1 year we see that this is due to calculation. 365 days we have in 1 year, and due to calculation this 1/4 day we just do not take it in 1 year. So from here we are now discussing the concept of orbit. So before that, let me show you some illustrations so that you will be able to understand it in a very distinct way. So this is Earth's revolution. Now this is the kind of this, you can see that this is the sun, this is the orbit, this path is the orbit, and this is the orbit, and the Earth's position is changing because it is revolving like this. This is a diagrammatic picture. So for ease of diagram, the sun is in the middle, but actually Earth's orbit is elliptical in shape. Now, so if you can see, you can see it from here. Now there is particular thing about orbit. Now what is an orbit? Orbit is, this is Earth's orbit or anywhere. Orbit means there can be comet's orbit, there can be moon's orbit. Now this orbit means path. Orbit is path. So what kind of path? It is a definite kind of path. So when our earth is moving, if this is the sun and this is our orbit and this is the earth, this earth will be always moving in this direction and in this path. It will always follow this path, and that is why in all the other 8 planets of our solar system has got their different kinds of path, but it is a definite path that, or definite orbit that they revolve around. If orbit was not there, then Earth and every other planet would have gone in any other direction, and in that way there would be a huge kind of collision. So that is a different thing. Now this orbit and this sun is placed in, not just in the middle. The sun is some kind of placed in one like this. Okay. So there is one distance, is it is not in the middle. If it would have been in the middle, then in the here it would be. But first of all, orbit is ellipse in shape or elongated in shape, and the sun is not in the middle. Sun is not in the middle. So what happens? When the earth revolves around the sun, there is a particular time when the distance of this becomes more and this is closer to the sun. So suppose our earth is here and our earth is here. So this distance and this distance from the sun is definitely shorter and longer. Now this has got a particular term. It is Mohan, you have mentioned about leap year, but there is one kind of thing, that is 365 and 5 days. It is not one revolution. Let me correct you. It is 365 and quarter day. This I will be coming to the concept of leap year after few minutes, but still let me tell you that this is 5 days is not the thing, it is quarter day, that is 6 hours, and this 6 hours in 4 years is accumulated into 24 hours, and hence in the 4th year we get one extra day which is added in February as 366 days. So coming back to the concept of orbit, now here you can see that this is the sun, this is the orbit, this is the closest distance. So this distance is called perihelion and the longer distance is called aphelion. Now peri means, here if we see the concept of perihelion, it comes from two words, that is peri, which means near, and helion means, it comes from Helios, that is sun. So near position to the sun is called perihelion. So this distance is called perihelion, and this comes closest to the sun is, the date is 3rd January or somewhere nearby 3rd January. Now the next position is this one, that is the further one, that is more or less near 4th July where we get, and this is called aphelion. Aph means, so this is aphelion. Aph means far and Helios is sun. So the farthest distance from the sun is called aphelion. So these are the two concepts of aphelion and perihelion. Now coming to the concept of the leap year. So now already we have mentioned that the earth takes 365 and 1/4 day. 1/4 day means 6 hours. So 365 days and 6 hours is one complete revolution. Now these 365 days, due to calculation or ease of calculation, we omit, while we calculate the days of an year, we always know that is 365 days is taken as 1 year, but we omit this 6 years in this thing. What we do, so where these 6 years go, these 6 years is actually we are adding it up for 4 years. So 6 into 4, so we are adding it for 4 years. So it comes 6 into 4, which is equal to 24 day and is equal to 1 day, 24 hours, sorry. So it is 1 day. So in the 4th year, we add this 1 day to 365 days. So 365 days plus 1 is equal to 366 days, and in the month of February we get this 1 extra day. This is what we call as leap year, and this is the reason why leap year comes for every 4th. So this is the concept of leap year and why leap year comes on every 4 years. So this is the thing, because this 1 year gets 1 or 6 hours gets added to 4 consecutive years to 1 day, and then it is added with 365 days. Now the next is very important, that is the effect of revolution. When we have discussed the effect of rotation, we have seen days and nights are caused, and to some extent there is an influence of the duration of day and night. But this duration of day and night is more prominent effect in case of revolution. So in revolution, the first and foremost thing is the change of season, or this change of season. So now we can see that sun is in the middle, the earth is revolving round it. So on this different position we can get different kinds of weather and different kinds of seasons. Now we know that we have got, in general, there are 4 kinds of season. 4 kinds of season. What are these 4 seasons? We generally get summer, then we have autumn, And the thing is that please remember, we are not discussing about climate or season of India. This is in general. On revolution we are talking about the types of seasons, because in India there is a huge kind of a season, that is monsoon and retreating monsoon. Here we are not going to discuss about that. We will be discussing it in any other chapter, but here it is the change of season is there, so I am actually speaking on that term. So, after summer it will come as autumn, then winter, and then we get spring. Now, summer particular kind of day is called summer solstice. That is what we get on 21st of June. Here you can see that is summer solstice, 25th of June, you can have this date. Now, as the earth revolves, suppose, and earth, we know that earth is tilted on its own axis. So, the earth has got a tilt. Due to this tilt, what happens on this day, the sun is directly overhead on Tropic of Cancer, that is northern hemisphere. So, if we take it like this, so this is the earth, this is a freehand drawing, and the earth is tilted on its own axis. So, this is north pole, this is south pole, and this is the equator. This is 23.5 degree north, this is south and all. So, and half degree south, 66.5 degree south. And this is 66.5 degree north. Now, the sun is in this position. It is on this day. The sun is directly overheating, so the earth is tilted in this position towards the sun, and as it is tilted towards the sun like this, you can see that the earth is tilted, the earth has got a tilt because the tilt of the axis, the earth is tilted, and so it is getting direct sun ray from this tropic in the northern hemisphere, or the whole of northern hemisphere is getting direct sun ray. So, it is getting direct sun ray in the northern hemisphere, and on 21st of June, this date is called summer solstice. So, this date the sun is directly overhead on Tropic of Cancer. So, as it is directly overhead on Tropic of Cancer, it receives direct sun ray, and on this day in northern hemisphere, not only we experience a summer, but also we experience longest day and shortest night. This thing reverses, it is just the opposite in southern hemisphere. So, in northern hemisphere we have this date, but in southern hemisphere we have just the opposite. So, it is winter over there. Why? Now there is a question like why there is a reverse, as it is tilted, Tropic of Cancer is directly overhead to the sun rays, but this position, as this is tilted, the southern hemisphere is away and they are receiving slanting rays. Like from here you can see the picture very clearly, like this is the earth's axis tilted over here, the sun is here, this is the sun, and it is the northern hemisphere is having direct sun ray, whereas the southern hemisphere, this is 0 degree, that is the equator, and the sun ray and this position is slanting rays. So as they have to travel a more distance, the light or the heat becomes lesser due to atmospheric things. So this region, as it is far away from the sun, is winter, and as this is directly towards the sun and it's a direct overhead, this area or northern hemisphere experiences summer. Now, and accordingly we say it as summer solstice, that is 21st of June, where we have got longest day and shortest night. Now what happens? Now this is on the Tropic of Cancer, what we can get. Here is the Tropic of Cancer, here is the equator, and here is the Tropic of Capricorn. But what happens in these areas means the polar region, that is the Arctic Circle and Antarctic Circle. Now you can see that the shadow circle over here is actually covering the whole of Arctic Circle. So here we get 6 months of constant daylight in the northern hemisphere. You can see as why again the tilt is towards the sun. In the northern hemisphere the tilt is towards the sun, and that is why the rays are reaching the whole of, it is covering the whole of this area, and that is why it is 6 months of daylight, or there is a summer for in these 6 months in this area. And the reverse happens here. What is there? The shadow circle, you can see that the shadow circle is actually covering, or night is covering the whole of the Antarctic Circle and this region. Again it is, as it is going nearby, see this is the overhead position, and as the sunlight reaches Tropic of Capricorn and the beyond, the rays are becoming very faint, and so from here it is hardly getting any ray, and that is why this region is complete darkness for 6 months. So this is the position of summer solstice. Now what happens after 21st June? So 21st June we got it as, so if we see 21st June we have summer solstice. Okay. Now what happens after 21st June? Longest day and shortest night. So why it is longest day slowly and shortest night? What happens? The earth, from here you can see that is, from here it moves in this direction. It moves in this direction, and slowly it seems, because it is the tilt, this tilt is slowly straightens. When it comes to this position we see that the tilt is not so much, so that this beyond the tropics they cannot or it is the apparent movement of the sun, you can say that it seems that the sun cannot go beyond the tropic. So after 21st June days starts shortening, days gets short, and the overhead thing, why days get short? Because the overhead sunlight is now decreasing, days shorten, and nights gets longer till a position comes where there is equal day and equal night, which is called equinox. Equinox means equal days and equal night. Equal, equi means equal, so week, and nox is day, so we get equal day and equal night, and what we called is as equinox. So this is the diagram where you can see, and here direct sun ray will be in summer solstice. Direct ray was on Tropic of Cancer. But on equinox we see that the direct sun ray is on equator. So here you can see that this is the direct sun ray, it is hitting equator. So this is the equator, the shadow circle is dividing both, and we are getting equal days and equal nights. This is same for northern hemisphere and southern hemisphere. So what we have here is, we have in northern hemisphere we have autumn, and here we get as spring. Now what is the date of this? It is in September. 23rd September we get autumnal equinox, where in the northern hemisphere we experience springtime. Now what happens after 23rd September? The earth is going to revolve, and it will come in a position where, and as it is revolving, what happens is that days become more shorter. So days was started shortening, so days goes more shorter and nights are more longer, till it come to a position where direct sun ray will be on Tropic of Capricorn. In southern hemisphere, and this day is 22nd of December, where in northern hemisphere we get as winter solstice. Now solstice is a term which means position of the sun. So you can see here winter solstice, that is 22nd of December. You can see the bigger picture is like this. The same thing, the sun is giving the sun rays, and here see, so this is facing towards the sun, I mean sun is directly it is direct sun ray the southern hemisphere is getting direct sun ray, whereas tropic of Capricorn is getting slanting ray. As it is getting slanting, you can see that how far the distance has become, and more above the tropic it is more black, and so the same thing happens is that the shadow circle is, if it's from here, so here in the northern hemisphere we are getting winter, 6 months of darkness in poles, and this day is called 22nd December, what we called is as winter solstice, where in northern hemisphere we get shortest day and longest night. We experience winter over here. So this is in the northern hemisphere, and the opposite happens in the southern hemisphere. Then what happens? Then again, due to Earth's position or Earth's revolution, this after 22nd of December, when it is directly on Tropic of Cancer, it seems that the Earth is again moving towards that equinox position. So days become, so it is moving, it seems that the direct sun ray is falling on, as it moves it's falling on the equator, it is directly hitting the equator, and again we are getting equinox, and here now what we have is spring equinox. So after winter or after winter solstice, days starts increasing in length and night gets shorter. And ultimately here we get equal day and equal night, and we call it as spring equinox. It is spring in northern hemisphere, and in southern hemisphere it is autumn. And what happens after that? It moves again towards this position. Days starts increasing in length, so it gets more and more, it gets increased in length, and night gets shorter, till again we come to the same position of summer solstice. And the tilt of the sun, slowly here the tilt of the sun is towards the northern hemisphere, is again towards the sun. So slowly as days get longer we also get, and as it is tilted towards the sun, we get summer till 21st June, where again we get summer solstice and the longest day. So this is all about the 4 position of the earth around the sun, and how winter solstice and summer solstice are there, and why there are 2 equinoxes. So there are, it is very important, you should remember there are 2 equinoxes that we come across. So this is all about rotation and revolution or movement of the earth. That is, you can see from here, this is for diagrammatic concept, that is how the earth revolves and in different position. So you can also have this thing. So you can have the diagram. So this is the proper diagram. So this much for today, and next day I will be discussing with you rotation, and there are other few concepts that I will be discussing with you. So goodbye class.